Okay, Chapter 2, Section 2. This is direct variation. Please follow along very closely. I'm going to go fast. This is not a difficult concept to grasp. Okay? You need to pay attention and you will be fine. Okay, this is actually one of the easier sections. If you can pay attention just for 15-20 minutes here, I'm going to give you lots of information. I just need you to try to pay attention. Keep up. Okay? Direct variation is when you have an equation y equals mx plus b, but it's called direct variation when the b is 0. When your y-intercept is 0. Does that make sense? Whenever b is 0, it's called direct variation. So it's going to look, if you add 0, it's just going to be y equals mx. So you just have a slope and a y and an x. That's it. Okay? The graph has to go through the origin, or point 0, 0. So let's look at these equations first before we look at the graph. Y equals negative 3x. Is that a direct variation equation?
Yes.
Yeah, because b is 0. There's nothing on the end. Yes, it is. What about this one? 3x minus 2. No, it's not. What about y equals 1/2 x? Yeah, there's b equals 0. Okay. When you have a direct variation equation, okay, you're going to have, if b is 0, it has to go through this right here, doesn't it? So that means they're going to look a lot like this. Right? There's one. There's another one. What about, okay. When you keep drawing these, you're going to end up having something that looks like a star. You see that? They're all going to go through the origin. It's going to look a lot like a star. Everything has to go through that in the center. Okay? Because your y-intercept has to be 0 in order for direct variation. Okay? Question?
How many lines do you have?
Infinitely many. Actually, if I draw them all, we just make a circle. I mean, these go on forever, but technically, I just have a big circle. I just drew examples ones for you. Okay? Now, if a linear function or a straight line is a direct variation, okay, or has direct variation, then any two ordered pairs, x1, y1, and x2, y2, okay, for any two ordered pairs, you can set up this proportion. So if you have any 2 points on the line, this has to be true. Okay? This has to be true. Well, let me ask you this. If I give you an example that looks like this, where 7, 5, and x2, can you find out what x is?
Yeah.
Yeah. If you label this x1, y1, okay, and this x2, y2, do this on your paper with the example. Okay, label them x1, y1, x2, y2. I can plug them into my proportion, so I'm going to have 5 over 7, that's my y over x, 5 over 7 equals 2 over x. And then I can cross multiply. I should still find it. So I have 5x equals 14, divided by 5, x equals 14 over 5. Any questions? Given 2 points where you're missing one of the x values, you can set up your proportion if it's direct variation, and you can find your x value. Not too difficult? Okay so far? Technical feedback. Good? I got 1 and 2 feedback. Something like that. Alright. Oops, wrong way. What about this? If y equals 3 when x equals negative 9, find x when y equals 5. Well, what are my 2 points? What? Yeah, negative 9, 3 is 1. What's my other one? It's x5, right? Because I don't know what x is. It says find x, so I need to find x. So how do I set up my proportion? I label this x1, y1, x2, y2. Set up in proportion, I have 3 over negative 9 equals 5 over x. Cross multiply, I have 3x equals negative 45. Divide both sides by 3. What's negative 45 divided by 3? Negative 15. Any questions? Given 2 points, set up a proportion, find your missing value. Now, this is a little difficult because we have a fraction in there, but don't freak out. You do it the same way. Okay? If y equals 5/17, when x equals 10, here's my point. Find y when x equals 5. Now I'm looking for y instead of x. Okay, so set up your proportion. This is going to be my x1, y1, my x2, y2. I have 5/17 over, I got a fraction over a fraction, I don't want that, but I'm going to do it. Y over 5. Now, you can solve this 2 ways. One, I can get rid of the fraction over a fraction, or just cross multiply, and it'll end up getting rid of itself. Okay, so cross multiply here, if you want, or you can get rid of the fraction over fraction by multiplying by the reciprocal. So I have 5/17 times 5 over 1, I just changed 5 to a fraction, so that I can multiply them, equals 10 times y. Now, since I am multiplying by 10, I could divide both sides by 10, or I want to simplify this first, sorry. Marry your tops, marry your bottoms, so I have 25 over 17. Now, I could either divide both sides by 10, but then I would have a fraction over a fraction again, and I don't want that. What could I do to get rid of this 10? Multiply by the reciprocal. I'm going to multiply by 110. 110 times 10 is just 10 over 10, which is 1. So multiply this by 110. Cross reduce. Divide by 5. Whoops. Divide by 5 would be 2. Divide by 5 would be 5. So I have 5 over 34. Here are my tops. Here are my bottoms. Please. These are in table. Questions? So far, so good?
No.
Questions?
Okay, is it like solving an equation?
Yeah, that's all I did. Instead of my proportion, cross multiplied, then solve for y. That's what I did. I just had a fraction in it, so it was a little different. That's what we did before.
Will these ever get any bigger?
No. Not direct variation.
Okay.
Okay. Direct variation is an equation with b equal to 0. It's always y equals mx. Now, however, with direct variation, rename the slope as k, where k is called the constant of variation. I don't know why they didn't just make it c. Maybe they can't spell. Okay, but yeah, k. K is called the constant of variation. When you have direct variation and direct variation only, you do not plug in k if there is a b. Only when b is 0, we call it k, because it's called the constant of variation, just to confuse you, not for any other reason. Okay? They just replace m with k, or k with m. It means the same thing. It's still the slope, but they say, okay, since it's direct variation, we're going to call it constant. Okay? That is not meant to confuse you. Don't let it confuse you. If you see a k, you know, oh, hey, direct variation. If you see an m, you know, oh, it could be. Isn't that crazy? It's always fun to test. Okay? Now, if y equals kx, how do I solve that equation for k? If I wanted to find k, by itself, how would you get k by itself here? Yeah, divide both sides by x. So is it fair to say y over x is equal to k? So if you have a point, can you find your constant of variation? If you have one x and one y, can you find your k? So let's look at some x's and y's. Make sure you have that written down, because you need to know this equation right here. So let's look at some x's and some y's on the next problem. Here I have some x's and some y's. I want to know if y varies directly with x, and if it does, I want the constant, or the k. Okay, constant stands for k. When you see constant, you do k, and write the function rule. Okay, which means the function rule, I need y equals kx. That's what you want. So let's look at this. Can I find k for the first one? For the point -2, 1, what's my k? -2 y over x, because that's what we said in the slide before. -2 over 1, which is just -2. So my k is -2. What about this one? -8 over 3 gives me -2 2/3. This one, 14 over 5 equals 2 4/5. Let me ask you, if the slope is -2 2/3, 2 4/5, do all these points lie on the same line? No, not if their y-intercept is 0. So do these vary? Is it direct variation? Do they vary directly with each other? No. They all have different k's. So if they have different k's, no. Let's go to the next page. Let's look at this one. Go ahead and find the k for each one. Let's do that. So I have my y over x. I'm doing same directions. I didn't read the directions. I guess same direction. So I have 6 over 9. And I'm going to divide the top and bottom by 3, and I'm going to get 2/3. That's my k. Then I have 8 over 12. Divide by 4, and I'm going to get 2 over 3. 10 over 15. I'm dividing the top and bottom by 4. I guess I divided by 4 doesn't work. Technical. Divided by 4 and 4. Over 15, divide top by 5, divide bottom by 5.
Why divide by different numbers? To reduce them.
Just reducing. I'm just reducing. I'm just showing what I'm dividing by. I reduced 6 ninths to 2/3 by dividing by 2, or by 3. I reduced 8
Oh,
twelfths
I
by
didn't
4.
have to, I thought I had to write that down.
No, you don't. I'm just showing how I reduce. If you know how to reduce fractions, you don't have to write that down. Now, the k for all these is 2/3. So does y vary directly with x in this one? Yeah, would they all be on the same line?
Yep.
What is the line? What's the equation of the line? What's the function rule?
Y equals 2/3 x.
Y equals 2/3 x. Because k is 2/3, so it's just y equals 2/3 x. You plug any one of these points in, it'll work. You multiply it by 2/3, it's going to work. X by 2/3 is going to work. Okay, does that make sense? We have one more type of problem to do, then we're done. Ooh, I might go till 2:07. Well, maybe not. All right. Determine the direct variation equation through the point 6, 5. Well, can you find your k if you have an x and you have a y? What is k?
5, 6.
Yeah, k is just going to be y over x, so it's just going to be 5, 6. Well, if k is 5, 6, what's the equation?
Y equals 5, 6 x.
That's it. Y equals 5, 6x. You just plug in your k once you put x over y. That's it. Do the next one by yourself. Pause. Okay, I'm going to find my k. Okay, I'm going to put y over x. In this case, this is y equals x. I'm going to put 15 over -7. Okay, just y over k. or y over x, and now my direct variation equation is just y equals kx. So, Lacey, what do? Y equals negative 15 over 7x, right? Don't forget that negative sign. Negative 15 over 7x, and that is it. You are done with today.
What about this one?
The last problem, oh yeah, I just do that one real quick. Okay, when a bike is being pedaled in a certain gear, it travels 10 meters for every 4 pedal revolutions. Okay, you guys know what a revolution is?
Yeah.
It's every time you go around with your pedals in a circle. Okay, that's a revolution. So if I go around in a circle 4 times, my bike is going to go 10 meters in this certain gear. Okay? So, can you make a point? Can you make one of those X and one of those Y?
Yeah.
Which one is the independent variable and which one's the dependent variable? Which one does not matter and which one does?
The pedal. Like rotation.
Well, if I go 10 meters, I'm sorry, maybe I should, we haven't talked about this yet. This is going to be my independent. I can choose whatever this is, but depending on what this is, depends on this. So this is my independent, this is my dependent, so my point is going to be 410. Okay, if you made 10 for, I probably wouldn't mark too many wrong, but technically, it should be 410 right here. Okay, and so let's keep reading. How many revolutions would be needed to travel 500 meters? Well, this stands for revolution, and this is meters, so what's my next point? Do I know the revolutions? No, it says how many revolutions, so I don't know it, but I do know my meters. This is revolutions, this is meters. Now, how do I set? Yeah, set up your cross multiplication. I have 10 over 4, this is y1, this is x1, this is y2, this is x2. So I have 10 over 4 equals 500 over x. Cross multiply, 10 times x, 4 times 500, 2,000, divide by 10. How many revolutions? 200.
So what's the other thing that I like that like a function?
Yes, ma'am.
Well,